Good morning. Welcome to another episode of Cyber Secrets. In this episode, we're going to talk about a new attack called HeartBleeding. It's just going to cover the basics, what OpenSSL is, what the problem is with HeartBleeding, and what some of the solutions are. To first understand HeartBleeding, you need to understand the basics of SSL, TLS, and OpenSSL. SSL and TLS work at the transport layer. So basically gives a way to encrypt things that do not have the capability of encryption, such as HTTP, POP3, SMTP, all your basic internet protocols. And at one point or another, everybody that's touched the internet has had to deal with SSL or TLS. OpenSSL is an open source SSL TLS solution, and it is used by a lot of very large organizations. Some estimates say up to 70% of the internet that's encrypted using SSL TLS technology is using an OpenSSL backend. So what is the problem? It's called HeartBleeding. To quote heartbleeding.org, the HeartBleeded bug allows anyone on the internet to read the memory of the system protected by the vulnerable versions of OpenSSL software. This compromises the secret keys used to identify the service providers and to encrypt the traffic, the names of the passwords of the users, and the actual content. This allows attackers to eavesdrop on communications, steal data directly from the services and users, and to impersonate services and users. Well, to be fair, this is a simple, stupid bug that any programmer could fix, and yet most programmers still make on a regular basis. Basically, someone forgot to validate a variable, just like 95% of the vulnerabilities out there today. Simple as that. Since it is open source, everyone had the opportunity to see it, but as most simple mistakes, no one did. It is not just the programmer that wrote the code that is at fault, but everyone that used the code because they all had the chance to look at it and fix it. The unfortunate result of this colossal blunder is that this one simple mistake made OpenSSL practically useless, since it would allow attackers to see the protected data anyways. This is not a call to stop using open source. It is a statement that everyone should understand that they could have fixed it if they cared to look. This is actually one of the biggest benefits of open source software. Now, to get a little bit more detailed, the HeartBleed attack works like a buffer overflow. The memcopy command copies data, but it has three variables. The first variable is the final destination of the data to be copied. The second variable is the location of the data to be copied. And the third variable is the amount of data to be copied. Just like a buffer overflow, if you alter the last section or the amount, you can start to read what is in the buffer. And like this old buffer overflow mentality, it comes down to trusting the variable without the validation of that variable. For example, if the payload claims to be 64K, but in reality it's only 0K, this is where you start to have some data leakage. I hear a lot of people ask, what's actually at risk? Well, your encrypted personal emails to your mistress, your bank account information including the dollars and money that you're hiding from your husband, your home security with cameras watching your kids while you're gone, national security. Yes, some brilliant people will actually put industrial control systems or SCADA systems connected directly to the internet or to a network that is. Your medical records, HIPAA, move aside. Your online dating profile, who needs to know the truth? Your online gaming accounts that you didn't spend hundreds if not thousands of dollars building. All of your social media accounts. Sadly, most of our lives are online nowadays, so everything you want to keep secret from the rest of the world can be accessible. So, what are some of the solutions? Well, first of all, update. Simple as that. Then change your password after you update. If you change it before, it defeats the purpose and you're still going to have to change it after you update. Once the bug's fixed, change it, fix it, it's all good. Next one. If you don't want to settle just for SSL or TLS, use some sort of defense in depth, such as VPN or IPsec VPN on top of that. A lot of organizations do not want to spend the resources, but that's still an additional solution. And another thing I do have to put in there, don't store things on the internet that you don't want your mom to see, or you don't want any sort of attacker getting to. Once you clear that, then a lot of the content that could potentially get compromised, it's not really going to matter. Now for some of the really bad news. I know this is something a lot of people are not going to want to hear. But if you were using a vulnerable version of the OpenSSL, you have to assume that some of the certificates may have been compromised. What happens when a certificate's been compromised? Well, first, you have to revoke the cert, issue a new cert to the registration authority, request a new cert from the certificate authority, issue that cert to the client, unencrypt all the data that's been encrypted with the old cert, re-encrypt all the data with the new cert, destroy the old cert. If you do not do this, that means you're doing SSL and PKI wrong. Some of the other SSL solutions, I have to get this off my chest. SSL has always been a potential security risk. What I mean by that is, as always, if you ever see an SSL certificate error, report it. You're either being hijacked or attacked, man in the middle for example, or somebody screwed up during the configuration. It is a security risk and is a stupid one to just accept from management's perspective. It doesn't matter if you have a smart card or any additional piece of the puzzle to help secure it. If you get an SSL certificate error, you're either under attack or implementation is messed up, so just fix it, and that gets rid of the security problem.
If you'd like to learn more about advanced information security, InfoSec Institute is a great resource at infosecinstitute.com.